that's me. I'm on the right slide now. So I'm looking at the timer there, and there's still 4 minutes of your session, Levi, so looks like I've got 20 minutes, which is a good thing. So I'm going to be talking to you this morning about BIM coordination. We're here at the BIM Coordinators Summit, and most of the presentation's about everything but BIM coordination. First of all, oh look, my numbers have gone down now. I'm Nigel Davies. I'm not going to say too much about myself. I just want to get on with the presentation, but I just do want to say that, you know, I've got experience in this. I've been doing this for a long time, both in this role and previous roles. By education, I was a structural engineering technician. Left that way behind me and kind of moved on now to look at information management, and particularly the exchange of information is where my kind of specialism comes in. And we work for a lot of different companies. We work on client side and we work on design team side, helping people adopt technology and move forward. And everybody gets confused and end up arguing, for want of a better word, about BIM coordination. So what is it? And why has it got people like lead designers arguing whether they've been paid to do it or not? What's a BIM coordinator? So I just want to take the first thing, just a little step back and look at, look. This is the kind of responses we're getting from teams at the moment. You know, we're not lead designer, there's no fee for BIM coordination. BIM coordination comes back to information management. You have to look at the two as a single part to understand what BIM coordination is and where it fits in the workflow. So hopefully you're kind of familiar with this kind of thing. This is a diagram that sets out the workflows of ISO 19650, starting with the establishment of the client requirements over there. Does that? No. Through to the design team. It takes into account all phases of a project. Information management covers everything. BIM coordination, however, just applies to this one part of the process. When you're excuse me, generating and checking and reviewing information during the design and construction phase of the project. That's where BIM coordination sits. That's often confused with information management. Typically, the BIM coordinator or BIM manager will be sitting here, dealing with the information, coordinating it, clash detection if you want to bring that kind of thing into it, and then feeding it back out. What BIM coordination isn't is the development of things like BIM execution plans. It isn't things like the responsibility matrices, the preparation of the information delivery plans. That's not BIM coordination. And what I guess I'm trying to say here is coordination has to happen. Whether you use BIM to do it or not is entirely up to you. And so what we're finding at the moment is that we're getting the lead designer saying we're not paid to do BIM coordination. We'll turn around to them if we're on client side and say, sure, okay, don't do it then. All we care about is receiving coordinated information. How you do that is totally up to you. You can do it by sitting there with drawings across your desk and marking them up and stamping them if you want and checking them, provided when we receive your information, we receive your models, they reflect that design and they are fully coordinated. How did Sir Christopher Wren manage before BIM was invented? He still got his projects coordinated. This is what happens, though, when we receive models where coordination hasn't been taken seriously. The first one you can see there is a great example. Okay, a simple clash detection would have picked that up. But if you think about that from a drawing perspective, there would be nothing wrong with the drawing at all. If you take the drawing section there about knee height, 1100 or 1000 mil above the floor, you're going to see a perfect design. You're going to see the stub wall coming up. You're going to see the staircase. You are not going to see that clash. So that's where the coordination effort wasn't done well. Not saying they had to use clash detection to do it, but if they'd reviewed the model differently and maybe had done it, they would have seen that and picked it up. The second one here would not have been picked up by clash detection. But just looking at it, you can see there's something wrong with that services outlet. there's something wrong with it because it's right in front of a door. Not only are you going to open the door straight into a service, you probably blown off your feet because the air's coming out there and venting out into your face. Interestingly enough, the example on the end is what happens when somebody else clash checks your model and doesn't understand what they're clash checking. That was a structural engineering practice that we worked for, got the clash detection back saying there are something like 900 clashes in your foundations. And they looked at it and they went, what? 900 clashes in our foundations? What they've been picked up on is clashes, any structural engineers here will be going, oh, duh, piles with the pile caps. And they picked all those up as clashes. And you kind of go, hold on, they have to clash. That's important because if the pile doesn't sit in the pile cap, it's not going to work. So you've got to understand more than just technology when you're doing this role. You've actually got to understand what it is you're trying to achieve rather than how you're trying to achieve it. And one of the things we start with on a project when we're talking about coordination, again, forget clashing. This is something we put in there anyway. What needs to be coordinated against what else? It's easy if you're a lead designer who is used to doing these kind of coordination processes to understand inherently what it is you need to check. However, the rest of the team may not appreciate that. And even if they do, because they're quite of experienced companies, individuals in the team may not understand what you're doing. So the first thing we start with is looking at areas where things shouldn't be coordinated. They don't need to be. So if you see here, just about read that on the example here, we're looking at things like fire protection and pipes going through ceiling finishes. At certain stage of the project, even at the end, that is totally irrelevant to the coordination process because what's going to happen on site, they're going to get something, they're going to be fitting in the finishes around the services, not worrying about where the holes go into a ceiling panel. If it was a structural beam, that would be a totally different requirement, but finishes, nobody cares because they're going to fit them after the stuff is actually in place. So that's the kind of thing we first do, is kind of start stripping it out. But that's got to be revisited at each stage. If you don't, you're going to end up, particularly with some other things. Let's have a look there. No, I can't think of one quickly, and I haven't got time to look through it. You know, where it's not important at stage 3, but actually at stage 5, it's critical. So that's got to be revisited every time. The other thing that has to be done right at the start of a project, which does my head in on every project, it's bane of my life, is where the project actually sits in real space. Why can't people get this right? It's even if they're using the same software. Every model you get at the start of a project is in totally different space. Or it may be in the right place when you look at it in plan, but then you switch to elevation, you've got one at 0, you've got one at actual level, you've got one sitting arbitrarily somewhere in between. Why can't you get that right? Do it at stage 2 when you know who the design team are, you know where the coordinates of this project are going to be, doesn't matter if it's exact, but get them to model a cube. It can be 1 meter by 1 meter. So long as they all get it in the same place, you've got a placeholder then that you can get this right. You cannot clash detect, you cannot coordinate information if it's not in the same space. First thing we do if we receive these, and here's the kind of check that we get here, is we will check things before we put stuff together. We will check each model individually. And I've had this discussion with a couple of other people, you know, our competitors who I get on very well with, who say, no, you can't do the validation checks on this information until the models are federated. What I'll look at is this. You check them first individually. You have to check they're in the right coordinate space. I don't even want to bother bringing them in together if they're not in the right coordinate space. We will look at this and we will say, okay, preliminary checks, are they in the right coordinate space? Are they formatted correctly? Have they got the right objects in them? Those kind of things. If the check is successful, we can carry on and federate it and carry on with Celebri, the tool that we use of choice, to check not only clashes, but the data and the construction of the models, materials used, those kind of things. If not, we'll report them back and get the team who built the model to re-deliver that. Put it in the right place. We are not checking it at this point. We're in a privileged situation, thankfully, when we're working for clients that they don't mind us rejecting the models. They've got their own work to get on with, probably off the PDFs and things like that. So they're worried at the end of stage the model represents exactly what's being delivered. If it doesn't, we'll send it back and get them to re-deliver it. But the other thing we've got to understand to do this is what are we doing it for? Most people do not have complex CAFM systems. They don't have them. Most of the people that we deal with go, oh yeah, facilities management, that's George's job. Who's George? He's the maintenance guy who replaces light bulbs and radiators at the bottom of the site. That's the kind of thing you've got to understand and appreciate this. He doesn't care about COBie. He's never going to look at COBie. He doesn't even know how to open a spreadsheet. What he wants to know, though, is where is that problem? What is the problem? What do I need to fix it? If you take that approach to even using technology on the most highly advanced projects, you're going to get better success. And that starts with something like these two photos here. The first thing you need to think about before you're leading on to facilities management and getting the information coordinated correctly in your model, what is a maintainable asset? I have yet to see one decent EIR, or AIR, whichever you want to think of, that we haven't produced, that tells us what a maintainable asset actually is. The last one we saw, produced by a very large practice, says a maintainable asset is IFC distribution element. What the hell does that mean to people actually sitting in front of their models? What's an IFC distribution element, they say? You've got to try and tell them that and work it out. What they need to know is, it's a tap. We need that because if that breaks, we can't use the water, we have to close down that kitchen, that tenant is going to be a problem. It's over here, the fire escape. If the mechanism's broken, we're probably going to have to shut that classroom. That has knock-on effects. Just two examples of it. Understand what your maintainable assets are in a wording and phrasing that people on the team and the facilities management or the tenant will understand. Not IFC whatever, it's a complete waste of time. The other thing to remember about coordination is it's not just final delivery. If we're starting to talk about data and we're talking about things like COBie, for example, I'm not going to get into explaining this kind of stuff now, it's not just for handover. You need to understand what data is needed at which stage of a project to be able to develop your information correctly. One of the best examples that we had was working for a university client who turned around and said, handover at the end is easy. What we need to know at stage 3, when we're actually looking at schematic design, is there water storage in with heating equipment? Because if that's the case, that's a breeding ground for Legionnaire's disease, we're going to have problems. So their data, they don't want to look at the model, they don't care about the data. They want a spreadsheet that says room equipment. Then they can look at the scheme and go, yes, that's satisfactory. Don't care what it looks like, is it safe? So that's something that we've done for them at stage 3. Room data sheets, effectively, that allow them to answer the questions they need at that stage. So that leads us on to kind of specifying COBie and how we do that. People just really don't understand what COBie is. COBie being a standard method of formatting the data within your projects so that it can be used. We come away from that, and while we're telling people on the left-hand side there's a specification to say what properties or what fields in COBie need to be filled out at which stage, we'll always try and back-end it. We'll always try and push everything to the construction stages as far as we can, because nobody will have priced for doing it at the early stages. So what you're going to get pretty typically is junk. So there are some things you need, but don't fight with people that every component has got a unique ID. At stage 3 and stage 4, it doesn't matter, so long as you can cross-reference that to the drawings or the schedules or the specifications. I don't care what they're called, so long as you can find them, identify them, and cross-reference all the data that's being produced. But what we'll do, and there's just a quick extract from it on the right-hand side, we will feed this back into our responsibility matrix, which shows elemental design, but also properties that are needed on each object type as they're delivering it at each stage. And this is what we show, because they don't care about COBie. What they've got there is a column that says, in Revit, or Open Buildings Design, or ArchiCAD, whichever software they're using, you need to fill in this property at this stage. That's what we want. And then we'll take them through in meetings to say, well, what type of data? There'll be a column in there to show example data that goes in it as well. So room number is needed at those early stages as a great example. The rooms will be numbered R1 for the floor, and then a sequential number after it. That's the kind of level of detail we go to. That's all that people need. Just follow that through for every piece of data that the FM system needs or George needs at the bottom of the garden to deliver. And you've got the information that you can then check and make sure it's correct at any stage of the project. And this is the other thing we do. we take the thought away from the design teams. Most people here now will be used to working with uniclass classifications on elements. You get used to it. Yeah, I can see a couple of nodding heads. What the FM systems want, they don't care about uniclass, they don't want it. What they typically ask for in maintenance is something called SFG20, which is a maintenance schedule. It's not really a classification system. It looks at preventative and precautionary maintenance and when things will need to be maintained or replaced. Nobody cares about that. So what we'll do is build tables that we can then ask, based on the asset and the final SFG20 code that needs to go into the FM system, if George is a little bit more technically savvy, what classification code needs to be used on the object. Because we'll get different responses from every person that we work with. A duct will be called something classified as SS, who knows whatever, in one company. The next company will do it under a project code. The next company will do it in something else. And it varies as you go along. What we need to make sure is we give that to them unequivocal. I can't say that on a presentation. Without doubt, they need to know which ones to use. So we'll tell them. Then what we can do is just set up the checking mechanisms and the mapping at the end, which we deal with them for. We don't care about the design team. Give us your models, give us an IFC. We will then handle the mapping from those elements across to the FM system. That's our job, not yours. You're employed to deliver and design. We're employed to do the handover and the FM side of things. So that's what we do. And just to finish off in the last minute, the things to remember about this is that to do that, you need educated information requirements. You need to be told what is actually needed. If not, then you can use the BIM execution plan to tell the client what they're going to get. But the important thing here is to remember that the BEP should be a single coherent response from everybody that actually answers the information requirements. It isn't just a list of this project and where it sits in space and how much it costs. Don't care about that. I want to know how you're going to deliver the information. So remember this. Are you looking at this as a BIM coordination task, coordination using software to help you coordinate it, or are you trying to manage the information? I would suggest it's the latter, and coordinating the information is just a way of getting there, no matter how you do it. You need to understand the actual requirements. Doesn't matter how you do it, I've said that over and over again, just get on and do it. You do it how you best do it, worry about the rest later. Don't let it become a tick box exercise. Do it for a reason that isn't just because it was asked for and it's going to get us ISO 19650 compliance. Don't let it become that. Do it for real. I'm up. There's my contact details. Catch me later. I'll hand back over. Woo.